All right, so we are recording our Unit 5, Day 3 Law of Cosines notes. The first 2 days were on Law of Sines. Law of Cosines is for when you can't use Law of Sines. Law of Sines is super easy to set up with ratios. Law of Cosines, it looks more complicated, but it's also super easy. And you're going to see some cases today where you would not have been able to start out with Law of Sines. So the first thing I want to do, because I'm looking at this formula, is I want to put letters on this triangle. So I'm going to call that one C, this one A, B. And so then where would little a be?
The opposite.
Opposite of big A, yep. Little b and little c. So the whole unit is about oblique triangles. Oblique is the fancy name for a triangle that's not a right triangle. And if you're given side angle side, or if you're given side side side, then you're going to want to start solving with law of cosines. Because in both of these situations, you're not given enough information for law of sines. You can take the same formula, and if you isolate cosine C, it looks like this. But notice they are the same formula. There's nothing new. Okay? Let me see if I can fix the focus. Okay, so same formula. This is just with the cosine C isolated. Sometimes people want to use this one to get the angle by itself, but I'm going to suggest try sticking with this one because it's a little bit less to think about. When we give you the test, we're going to give you this version, so if you start using this version, you might get a little confused with the extra steps that you need for this version. Okay. So in case 1, we have this triangle here that we're given PQ and angle R. So notice different letters here. Let's see if we can set it up though. We're trying to find, let's see, we're going to start by finding the side that's opposite this one. Find side R first. So it's going to start with R squared equals. And then instead of a squared plus b squared, what letters do we have? P and Q. Minus 2, instead of AB, what letters should I use? P and Q, right. See, these two are going to match these two. Cosine. And then what angle goes there? See, it's going to be the 58. It's going to be angle R because this C matches this C. So this R is going to match this R. So all I did was rewrite the formula with different letters. And now we're going to put the numbers in. Okay, so R squared is what we don't know. 6.5 squared plus 7.4 squared minus 2 times 6.5 times 7.4, and then cosine 58. One mistake people make with the law of cosines is that they try to combine things that can't be combined. All of this is one thing. Okay? So you can't separate that. What I'm going to suggest is just put the whole line into the calculator at once. So grab your calculator, and we're going to put the whole thing in. 6.5 squared plus 7.4 squared minus 2 times 6.5 times 7.4 cosine 58. Okay, did I find R yet? Yep, we're going to do square root. Do you guys remember what exponent is equal to square root?
1/2.
It is 1/2, yeah, good. So sometimes instead of doing square root of the answer, I just raise it to the 1/2. It's the same as square root though. All right, so I get 6.8. Are you guys getting about 6.8?
Yeah.
Okay. So what else are we missing in this triangle? I have side R. I have my given information. What else am I missing? Yes. Oh, yeah. Thank you. So I have side R and I have the given information. What else do I need to find? Yeah, I have to find the other angles. Good. Okay. I have 3 sides. They're all about the same. So probably none of my angles are obtuse. However, here's one rule to keep in mind when you're doing a law of cosines problem. What I'm going to do is I'm going to switch over to law of sines. Most people do that because law of sines is easier than law of cosines. Once you find one piece of information, you can switch over. But a really good thing to remember is if an angle might be obtuse, don't find it with law of sines. So never use law of sines for an obtuse angle. Okay, so like I said, I don't think any of these are obtuse, but just in case, let me look at my 3 sides. 6.8, 6.5, 7.4. Which one's biggest? 7.4 is biggest. So if any of these angles are obtuse, it's going to be angle Q. So I'm not going to find angle Q, I'm going to find angle P. Okay? So I'm going to do P over sine P. Equals, and then I just found this one, R over sine R. Cross multiply. Divide. Okay, so let's find out what sine P is. Make sure you're in degree mode.
Oh, Ms. Burrell, what I usually do is I would do 6.5 sine 58 first and then divide that by 6.8. Would that work?
Yeah, sometimes when you're dealing with fractions, it's helpful to do the whole numerator first, but in this case, because we're only multiplying in the numerator, it's going to work otherwise. But yeah, your method is a good general method. Yes?
How do you know that the triangle isn't obtuse?
So I was looking at the sides, and I was thinking the sides are all pretty close together, like 6.8, 6.5, 7.4, which means it's probably close to an equilateral triangle. Not exactly, but kind of close to it. An equilateral is going to have all 60-degree angles. So I'm thinking that these angles aren't going to be very far apart. It was just a guess, though.
So like if they were different numbers, how would you know?
So you don't really know, so you always want to find the angle that could not be obtuse. Remember that a triangle can only have one obtuse angle, and it's going to be opposite the biggest side. So just don't use law of sines to find that angle, and you're good. So did you see that? Like I said, if there's going to be an obtuse angle, it's going to be angle Q, if there is one, because that's the biggest side. So I didn't find angle Q with law of sines. I found angle P. I haven't quite finished yet, though, so let me finish finding angle P. All right, so I'm going to write down sine P equals 4 decimal places, 0.8106. And then I'm going to do inverse sine. So did you guys get 54.2-ish? Okay.
54.16 is what I got.
Okay. All right, so I said I'm not going to find angle Q with law of sines. How can I find angle Q now?
Just subtract subtract the two angles.
Yeah. So Q is going to be 180 minus the angles that I found. Minus.
Should I round 54 down to just, 54.16 down to 54?
I didn't give you rounding directions on this one, so you could, but I would prefer you do one decimal place if you don't have directions.
Okay.
So 180 minus 54.2 minus 58. So 67.8. Okay, did we find everything?
Yeah.
Okay, talk to your group for a minute about whether or not we need to check for a case 2. Talk to your group.
No, it's only side side, and that's what wait, that is side side.
I'm not going to check.
You know what else I learned on the road when I was driving from.
All right. Raise your hand if you think we need to check for a second case. Raise your hand if you think we don't need to check for a second case. All right. I am mostly disappointed that less than half of you voted. So let's try this again. All right, just take a stab at it. No, it's a good question. I mean, that's like the heart of the question, right? How do you know if you need to check for a second case? That's a good thing to think about. All right. So this time, if you're not 100% sure, just take a guess. Raise your hand if you think that we need to check for a case 2. Raise your hand if you think we don't need to check for a case 2. Thank you to everybody who voted. I appreciated both sides of that argument. All right. You only need to check for a case 2 if you're given what?
Side angle.
Side angle. So the question is this side angle, right?
Yeah.
Well, we are given 2 sides and an angle. It says side angle side here, so that makes me think that's different from side angle, but I'm going to draw a picture to convince myself. So here's a picture of PQR.
So we did need to check.
I'm not sure yet. I'm working on it.
But you're checking.
All right, well, I'm checking. I'm given side P. I'm given side Q. And I'm given angle R. 58. So this is side angle side. All right, so you don't have to check for side angle side. And here's the good news. Law of cosines problems are side angle side, side. There's never a second triangle for those. In geometry class, you guys learned that if you have side angle side, then it's always going to be congruent with another triangle that has side angle side. Same with side. Okay? So there's only one triangle for side angle side and side. What other questions do you guys have before we go on to case 2? Okay. Case 2 is given side. We're given the letters A, B, and C, so I can stick with this one right here. It says find the size of the largest angle. So the largest angle is going to be opposite of which of these?
It's going to be opposite of C.
C. Good. C squared equals A squared plus B squared minus 2AB cosine C.
You're giving us these formulas on the test?
So I'm giving you the first formula. Okay? That's why I stuck with that formula. Now I'm giving you the formula with A, B, and C, but if it's P, Q, and R, then you got to figure out how to substitute those in. 13 squared equals A squared plus B squared 9 times 10 cosine C. All right. So, like I was telling you, a common mistake is people combine things they think that they're allowed to combine. This last part is all one term. It's all stuck together. That's all stuck together there. So we need to figure that out separate from everything else. We can figure these out. What's 13 squared?
169.
Good. And 9 squared plus 10 squared.
189.
Close.
181.
Very good, guys. 181. And then I can combine the negative 2 times 9 times 10. What's negative 2 times 9 times 10? All right. Raise your hand if you can figure out what mistake half the people will make in this step. But not you guys. Okay, nobody raised their hand, but half of you participated, which is good. Okay, so yeah, you can subtract those two because this one's stuck on the cosine C. So don't do that. Instead, how could I try to isolate the cosine C? What could I do to both sides? Subtract 181. Good. So do that. Tell me what you get. Okay, so we get negative 12 equals negative 180 cosine C. I haven't isolated the cosine C yet. What's the next step? Divide. Good. Point 0.0667. All right, so then we're going to do inverse cosine. Notice that all of a sudden we're doing inverse cosine instead of inverse sine because this is law of cosines. So I get 86.2 degrees. Okay. Did I answer the question?
Yes.
Yeah, I just said to find the largest angle, so we did that. All right. Now we have our real world problem. A boat travels in a straight line from a pier for 3 miles, then it makes a 45-degree turn and goes straight for an additional 6 miles, and then the boat travels straight back to the pier. And how long is the last leg of the trip? All right, so let's start with the pier. There's the pier. And it goes for 3 miles. Till it turns. Alright, so here's the tricky thing. If it's turning from straight 45 degrees, the angle in your triangle is actually going to be a big angle. See, that's the 45 in here. And it goes straight for 6 more miles. And then what happens? And then it goes back to the pier. So this is when it starts heading back. Okay. Yes. That's right. Very good. Okay, so Corinne and Natalie are pointing out since this is a straight line, 180 degrees, we can deduce that this is 135 degrees. Very good. So now what are we given? Is this side, 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 angle, side, side? What is it?
Side angle side.
Side, angle, side. So this is a good one to do law of cosines on. And we're going to use these letters. So since I'm given angle T, I'm going to start with T squared. Okay? Remember that whatever angle you use, you start with the side opposite that one. So So t squared equals p squared plus b squared minus 2. And then instead of AB, what letters should I use? PB, good. Okay, so let's put the numbers in. We don't know t, right? All right, and then let's put that whole thing in the calculator. So I get 70.5. Actually, I'm going to put more decimal places down since I have to square root it. 70.4558. And then square root that. .4. Okay, so question A, say that again? Oh yeah, definitely. So question A is how long is the last leg of the trip? And I wrote 8.4, but Christine says I need to put down what unit? Miles. So 8.4 miles. How many degrees did the boat have to turn to head back to the pier? So that's angle B. Do you think angle B might possibly be obtuse?
No.
Why can't angle B be obtuse?
We've got our obtuse angle.
Yeah, we already have an obtuse angle. Very good. All right, so we can do law of sines with no problem to find angle B. Let's see. So we're going to do B over sine B equals 8.4 over sine 135. Okay, so I'm going to do the right side first. And then what do I need to do to find B? Inverse sine, good. .6 degrees. Okay. What questions do you have on that one? All right, so we are going to do some practice problems after this. Let me stop the video. I'm going to put this video on Blackboard. On the top of here, it says that there's a video link, but I actually tried this one and it wasn't working. So I'm going to give you a new video and I'll put that on Blackboard if you need to see these notes again. All right, how do I stop my recording?